Hey guys, we're going to write code in this video. I know how this is the most fun part, but there's something really important we need to understand, and that's data types. So let's get started. In Java, every piece of data we use, whether it's a number, a letter, or even a true-false value, needs a type. That's how the computer knows how to store and work with it. Now, Java gives us two main categories, the primitive data types and the non-primitive data types. So what's the difference? Primitive types are the basic building blocks. They are simple, efficient, and store actual values in them, like numbers or characters. Non-primitive types, on the other hand, are a bit more complex. They're built using primitive types, and an example for them is a string, like storing an actual word. So they store references to the data instead of the actual value itself. For now, let's focus on the primitives because they're the foundation for everything else. So, what are the primitive types? Java gives us 8 primitive data types, which are the byte, short, int, long, float, double, char, and boolean. You'll notice how they fall under different categories. Some are used for numbers, like byte, short, int, long, float, and double, and others are used for characters and booleans. This is just a reminder for you guys that everything is stored as binary in the computer. Binary is made of bits, 0 or 1, so it has two possible digits, and a 1 byte is equal to 8 bits. Now, here's something important to keep in mind. Each one of these types is stored using a fixed number of bits in memory, and that's going to affect how much they can hold, so the value that they can store. For example, a byte is 8 bits, short 16 bits, int 32 bits, long is 64 bits, and for decimal numbers like float, it can store 32 bits, and double can store 64 bits. A character, which is a single letter, is usually stored in 8 bits. So why do these sizes matter? Because they directly control the range of values that each data type can represent. Now I want to show you what that range looks like for each one and explain why, for example, an int can go from around negative 2 billion to positive 2 billion. So just a quick note, what we've explained so far in the last video, like how you can represent numbers from 0 to 2 power n minus 1, this was the case for only positive numbers. These are called unsigned numbers because they don't have a negative side. But in Java, most numbers are signed. This means that they can store both positive and negative values. So instead of going from 0 to 2 power n minus 1, the range is typically from negative 2 power n minus 1 to 2 power n minus 1 minus 1. This is the new range covered. To understand why, you have to understand the 2's complement, but I didn't really explain it because I thought it would be a bit more complex. So just for your own information, if we have 3 bits, so this means we have 3 digits concatenated with each other, either 1 or 0. So for instance, we have 1, 0, 0. Then this means that the range that could be represented using 3 bits is negative 2 to the power of 2 up till 2 to the power of 2 minus 1. This is our full range of numbers that we can represent using 3 bits. This would just mean that we can store numbers from negative 4 to 3. And just for your own intuition, or a reason for that, is because in 2's complement, we represent negative numbers by having the leftmost bit as 1. So in this case, this would be a negative 4. So this is why if we want to represent a positive number, the leftmost bit must be 0, and therefore we only have 1, 1. So this is the greatest positive number that can be stored using 3 bits, which is 3 in this case. This is just an intuition, but I wanted you guys to understand this. The number of bits for the int, long, and so on, this is the difference between them, just the range that can be represented in each. So one last thing. So for byte, we said that a byte is a total of 8 bits, right? So in this case, this means that we can store negative 2 to the power of 7. Sorry if this is not really clear. 2 to the power of 7 minus 1. So this is the range that a byte can store. It cannot store anything smaller than negative 2 power 7, and anything bigger than 2 to the power of 7 minus 1. So this means that the range of a byte is negative 128 to 127. Okay, so I attached the folder. You can download the zip folder and just open the project in IntelliJ. But I hope you really start the project and create one yourself, because this will give you more practice to understand classes and memorize the signature for the main method. So I just created a project. I called it 0 to primitives intro. And then I went ahead and right clicked on the source, went to new Java class and wrote here primitives to create a new class called primitives. So here it is. I will just write here the main method in order to be able to write my code and run it. So public static void main string length. Now I want you guys to try out the primitive types that we've mentioned. So in this case, we just have to specify the type of the variable. So I will just specify it as byte, and I have to give it a name. Price is equal to 127. And let's just system.out.print the price. So let's try to run this. So as you can see here, it printed the 127 because it's still in the range of the byte. It can be stored. So let's go ahead and try to write 128. It gives a direct error because 128 is out of the range of a byte. So a byte cannot store a 128. Okay, so I want you guys to go ahead and change this byte a short. So 128 is definitely in its range. Let's go ahead and try to write a very big number. Now 200,000 is not in the range, so required type is short provided int. It's telling you that 200,000 is out of the range of short. So if we change short to int, the error disappears because 200,000 is in the range of int. So this is why understanding the range that each type can store is really important. So before we proceed to the next video, I wanted to apologize again and clarify that the char is stored in 16 bits in Java. And before we proceed and focus on the main primitive types, diving deeper into each separately, I want to quickly show you how to fix the error we get when we try to assign 128 to a byte. More importantly, let's also see what actually happens when we force it using typecasting and why the result might surprise you. So let's head to the next video now.